Good morning, students. Welcome to Sri Guru online classes. Let us discuss the lecture number 2. In the last class we discussed the types of emissions, electron emission also we discussed, and the basic difference of radiations and matter we discussed in the last class. In this today class I am going to discuss the very important concept, that is photoelectric effect. Photoelectric effect. Photoelectric effect. What is mean by photoelectric effect means, already we discussed the definition of photoelectric in the last class. The emission of electron from the metallic surface when a light of suitable frequency is incident. The phenomena of emission of electron from the metallic surface by giving a suitable frequency or incidenting a suitable frequency on it is called as photoelectric effect. What is mean by photoelectric effect? The phenomena of emission of electron from metallic surface incidenting a suitable frequency. A phenomena of emission of electron from metallic surface, suitable frequency is incidenting on it. Suitable frequency is incidenting on this metallic surface is called as photoelectric effect. And this photoelectric effect first observed by Heinrich Hertz. The first observed by the scientist Heinrich Hertz, and he observed the initiation of photoelectric effect. What he observed means, when light is incidenting on any metallic surface, that metallic surface illuminated by a high voltage spark. He observed that the emitter or any metallic surface which is emitting electron from that particular metallic surface, the conduction takes place. Just to consider the observation of Hertz observations. Hertz observations, just to consider here a metallic surface. Between this metallic surface, a high voltage sparks developed between this conduction plate. Here sparks develops, and he kept a detector loop near to this metallic surfaces. On this metallic detector also high voltage spark, this is called as a detector loop. On this detector loop enhances the high voltage spark when it was illuminated by a certain light of frequency. This is the first observation done by Hertz, and this is the initiation of photoelectric effect. What he did, when light of suitable frequency is incidenting on this metallic surface, a high voltage sparks developed between these plates, and near to these plates he kept a detector loop. On that particular loops also enhances the sparks, lightning, the intensity of that particular surface, the shining of that surface is enhanced, increased, the voltage spark is going to increase on that particular detector loop. This was observed by Heinrich Hertz, and this is called as photoelectric effect, and this is the initiation of photoelectric effect. Now come to the second observation, observed by Halbach and Lenard's. Before going to explain the Halbach and Lenard observation, and these type of electrons are called as photoelectrons. What is meant by photoelectrons? When light of suitable frequency is incidenting on the metal surface, on that particular metal surface there is n number of loosely bound electrons. Those electrons will emitted from that particular surface. Those emitted electrons is called as photoelectrons, and these photoelectrons conducts a current is called as photocurrent. Photocurrent. Once again please listen here. What is mean by photoelectric effect? The phenomena of emission of electron from the surface of metal incidenting a suitable frequency on it. The emitted electrons are called as photoelectrons. The current produced these due to these photoelectrons are called as photocurrent, and this was observed by Heinrich Hertz. Doing this experiments continued by many scientists, Einstein's and Lenard's, Halbach. They continued these observations and they explained successfully the photoelectric effect. Now come to the Halbach observations. Very important observations by Halbach. Halbach also explains the photoelectrics effects on the different metallic surface, but he considering the zinc metallic surface, that too negatively charged zinc surface. Negatively charged zinc surface. Gold leaf electroscope. These are negatively charged zinc surface. Negatively charged zinc plate. When light of suitable frequency or when a UV light is incident, UV light, ultraviolet light is incidenting on this metallic surface of a suitable frequency is incident, the electrons are emitted from this surface, and he observed that negatively charged zinc surface, when it was illuminated by a light of suitable frequency, that is UV light is incidenting on a negatively charged zinc plate, it becomes neutral. All these electrons negatively charged are removed. Electrons are going to remove. Negative charge is removed, and this is the first observation by Halwaj. What he observed? When UV light is incidenting on the negatively charged zinc plate, the negative charge are removed, it becomes neutral. So negatively charged zinc plate lost its negative charge when it was illuminated by UV light. The first observation is, when a UV light is illuminated by this negatively zinc plate, lost its negative charge. This is the first observation by Halwaj. And second observation, now it is no charge, there is no positive charge and there is no negative charge. Initially this plate is negatively charged. After incidenting a UV light, those negatively charged are lost. Now it is neutral. Again a UV light is incidenting. Again a UV light is incidenting. Again a UV light is incidenting. It becomes positively charged. It gains positive charge on the particular zinc surface. It gains the positive charge. First he observed a negatively charged zinc surface was illuminated by UV light. It lost all the negative charge. It becomes neutral. It becomes neutrals. Again a UV light is incidenting on that particular neutral. It becomes positive charge. Again this positive charge was illuminated by UV light, means more number of positive charges. Hence conclusion is, a light of suitable frequency is incidenting on the zinc plate, the removal of negative charge. Negative charge means the emission of electron from that zinc metallic surface. Now consider here. Initially, just to consider, this is a zinc plate. This is negatively charged. When it was illuminated by UV light, it becomes neutral. There is no charge. Why? Because all the negative charge are lost due to this illuminated by UV light. When again it is illuminated by UV light, it becomes a positively charged surface. This is initially, this is a zinc plate, negatively charged zinc plate. Negatively, this is also zinc plate. It becomes neutral. Why? Because all the negative charge are removed due to UV light. Electrons are going to remove. Again we illuminated by this neutral zinc plate. It gains a positive charge on this particular zinc surface. This was observed by Halwaj. Halwaj observed that a negatively charged zinc plate becomes positive. It means that the removal of electrons from that particular metallic surface, that too zinc metallic plate, by the experimental setup of gold leaf electroscope. He observed from this gold leaf electroscope, a negatively charged zinc plate will become a positive charge. Removal of electron by illuminating a UV light is called as Halwaj's observation. This is the conclusion. What is the conclusion of Halwaj's observations? The conclusion is that of negative charge from the zinc plate when it was illuminated by UV light. This is the conclusion of Hallward's observations. Now come to very important observation. Leonard observations on this photoelectric effect. Leonard observations. Okay, this Leonard's observations on photoelectric effect. Leonard observations on photoelectric effect by experimental setup. Just to consider evacuated glass tube. Already I mentioned this diagram in the printed notes also. This is a evacuated glass tube. It was illuminated by this is a quartz window. Here two electrodes are fixed in this evacuated tubes. This we call as cathodes and this we call as anode. This is C for emitter plate. And A for collector. Collector plate. When it was connected to particular instant, it is incidenting on the rheostat. This is key. This was connected. Now here the ammeter, that too micro ammeter. When source of light is incidenting, when a source of light is going to incident, or you just to consider in the form of wave, it is going to incident, and here the ejection of electrons and these collector plates are going to collect the electrons. When a suitable frequency of light is incidenting on this collector plates, the electrons are emitted from this cathode and which was collected by anode plates. Leonard observed that when light of suitable frequency is incidenting on the cathode plate, that is emitter plate, and the electrons are emitted from this plate and which was collected by anode, and the conduction starts, and this is called as, or it is going to change the potential difference, the variation of potential difference. This is initially, this is negative and positive. If this commutators change like this, it becomes negative and it becomes positive. This is the experimental setup, and this the variation of resistance, if we increase the resistance, the potential difference increases. The potential difference means increases means photocurrent is also increases. When light of suitable frequency, this minimum frequency, when UV radiations falls on a emitter plate, UV radiations falls on a emitter plate, the electrons are emitted, and these electrons will collected by that anode. There is a conduction takes place. We are seeing how much current is increases in this microammeter device. On this particular microammeter device, we are going to see the current variations. Already I explained this, we called as a evacuated glass tube, and finally concluded that Halvach and Leonard observed that the minimum frequency of incident light, below which there is no emission of electrons, that minimum frequency is called as threshold frequency. That minimum frequency, the frequency below which there is no emission of electrons, that frequency we call as threshold frequency. Below threshold frequency there is no emission of electrons. That minimum energy is equal to work function of that particular metallic surface. This was observed by Leonard's and Halvach's observations. What Leonard observations mean? When light of suitable frequencies incidenting on a cathode plate, this plate emits the electrons, and this another electrodes collect those electrons. There is a conduction starts on this circuit, and this cumulator help us to variation of potential difference with the variation of this resistance. The resistance increases, the potential difference also increases, the photocurrent is also increases. This was observed by Leonard observation. On the today class we discussed the three observations, very important observations. Once again we see in the tabular forms, in the difference forms. Once again see, the next class I am going to explain the experimental setups of Einstein. First observations, Hertz observation, Hertz observations. Second one is Hallward and Leonard combinedly they observed just see one by one. Once again see in briefly, Hertz observation means Hertz observed that when a metallic plate is illuminated by a UV light, a light of suitable frequencies incidenting on this metallic plates, the high volt sparks are developed between these plates. A detector loop enhances high voltage spark. When a metallic plates between this conduction, light of suitable frequencies incidenting on this metallic plates, the high voltage sparks between these plates, a detector loop is placed near to this setup. In this detector loops enhances the voltage spark, increases. This was first observed by Heinrich Hertz, and this is the initiation step of on photoelectric effect. This is the first step to develop a photoelectric effect. And Hallward observations, already we have studied. A negatively charged zinc plate, he considered the negatively charged zinc plate and this negatively charged zinc plate was illuminated by UV light, This negatively charged zinc plate becomes neutral. Why? Because all these negative charges are lost. Negatively charged are removed. The zinc plate becomes positive. Or you just consider neutral or some positive charge. Some of the positive charge. Again he observed that when a light of suitable frequency was illuminated, this some positively charged zinc plate becomes more positively charged. He concluded that we can see here almost all we are going to remove the negative charge. Negative charge means we are giving the electrons, removal of electron from the surface of that zinc plate. This is more number of positive charge. Again we increase the, or again we are illuminated UV light, means definitely it is more and more positive charge gained by that zinc plate. This is the Hallward's observations, the removal of negatively charged ions from that zinc plate. And Leonard observation, when light of suitable frequency is incidenting on the evacuated tubes, on this particular evacuated tube, this is cathode plate and this is anode. This we called as emitter plate, and this is collector plate. And this is evacuated glass tube. And we can see here plug key, here is battery, and here we observe the current through this ammeter, that too micro ammeter. This is key, this is battery, that is positively charged, and this is we call as commutator. Leonard observed that when a UV light or a suitable frequency is incidenting on this, there is an emission of electron from a metallic surface, emission of electrons from this metallic surface, and which was collected by that anode, and that we called as a collector plates. And this is the three observations, and very important observations, just keep in your mind. On photoelectric effect, main observations and very important observation, first discovered by Heinrich Hertz. Photoelectric effect was discovered by Heinrich Hertz in the year of 1887, and he observed that a high voltage spark is enhanced on the detector loop, and the continuation of this was observed by Hallward and Leonard. Hallward, considering on the gold leaf electroscope negatively charged zinc plate, he considered when a UV light is incidenting on this negatively charged zinc plate, the removal of this negatively charged ions. Why? Because UV light is going to incidenting on that zinc plate. Again he illuminated by that UV light, again the more positively charged ions are developed on that zinc plate, the removal of negative ions. It means that electrons are emitted from that zinc plate. This was observed by Hallward, and Leonard observed on this particular evacuated glass tube source, any type of light which is incidenting frequency or intensity of light is incidenting. As intensity of light goes on increases, the currents on this particular circuit is also increases. You can change the polarity by using this cumulator. These are the observations. It is not necessary to discuss too much. Why? Because these are the observations on the photoelectric effect.